Good morning, children. In today's class, we are going to learn about pair of straight lines. Pair represents two. Suppose I draw a line through the origin, say L1. Another line through the origin, say L2. There are two lines. How will you write line 1? Y equal to M1x plus C1. Or because it is passing through the origin, it is only Y equal to M1x. When I drop a second line, I can call it as Y equal to M2x. Now, what is the combined equation of the two lines? First line is y minus m1x. Second line is y minus m2x. Let us multiply. As I multiply the two equations, I get y into y square, minus m2xy minus m1xy minus into minus plus m1 m2x square equals to 0. So there is a y square term, there is an x square term, and there are two xy terms. I read it as m1 m2x square minus m1 plus m2 into xy plus y square equal to 0. Suppose the two lines are not through the origin. They are anywhere like this. In that case, I will write the general second degree equation. What is the general second degree equation? Here I have x square, xy and y square alone. Now I will introduce x term, y term, constant term. So let us remember general second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. This will represent a pair of straight lines if it satisfies a condition, say ABC plus 2FGH. How you remember ABC, first three alphabets? The next three alphabets that come in this equation are FGH. So next three. So put twice. For remembering, remember the clue. Minus A, minus B, minus C. F square, G square, and h square, that is equal to 0. Remember the condition. If the general second degree equation satisfies this condition, we will declare this equation represents a pair of straight lines. Now, what is the angle between the two lines? How to get the angle? I call theta as the angle. Then we say theta equals tan inverse 2 root of h square minus ab by a plus b. Angle between two lines, we declare the formula tan inverse 2 root of h square minus ab by a plus b, where a is the coefficient of x square, b is the coefficient of y square, and h the coefficient of 2xy. So given an equation, whether it is passing through the origin or not, we have the same formula because angle depends only on ABH. Now the next idea. Already we had y equal to m1x and y equal to m2x. If I consider the pair of straight lines through the origin as ax square plus 2hxy plus by square equals to 0, then comparing this and this, we get m1 plus m2 is minus 2h by b and m1 m2 is a by b. So if m1 and m2 are the slopes of the two separate equations of the lines, we can compare m1 plus m2 with minus 2h by b, m1, m2 with a by b, where a we treat as the coefficient of x square and b we treat as the coefficient of y square. 2h is the coefficient of xy. As we know all this, let us list out all the formula. Here, the angle between, we have taken the formula as 2 root of h square minus ab by a plus b. We know if the lines are parallel, the angle between them is 0. In that case, the numerator should become 0. So, I have the condition h square minus ab 0 or h square equals to ab. Suppose the two lines are perpendicular. Angle is 90. It is tan inverse infinity. That is the denominator 0. We have the condition a plus b equal to 0. So, if the lines are parallel, h square minus ab 0. If the lines are perpendicular, a plus b equal to 0. So, let us list out all the formula. Pair of lines passing through the origin ax square plus 2hxy plus by square equals to 0. Angle between the pair of lines theta equals tan inverse 2 root of h square minus ab by a plus b. Put the modulus, we treat only the acute angle between the lines. The lines are parallel if h square minus ab equal to 0 or I can say h square equals ab. The lines are perpendicular if a plus b equals to 0. The general second degree equation to remember ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Here, degree of every term same. We call this as homogeneous when the degree of every term is same. Here we have the general second degree equation. We have the power 2, power 1 and no power also. This will represent a pair of straight lines if A, B, C first three alphabets plus second three alphabets, remember to put 2, F, G, H minus A, B, C. Here in order F square, G square, H square equals to 0. This condition can also be written in determinant. Diagonally fill A, B, C. In the reverse order F, G and then H. So F, G, H. In the reverse order we write the next three letters. Diagonally A, B, C. In the reverse order F, G, H equals to 0. Either use this or you can use determinant notation. The last equation to remember, the equation of pair of bisectors. Suppose I have the two lines like this. You have the bisectors. How to write the equation? The angle between the lines is bisected by these lines. How to get the equation? It is x square minus y square by a minus b equals xy by h. Let us remember these formula and apply suitably in the exercise problems. Exercise 6.4, question number 1. Find the combined equation of the straight lines having the separate equations x minus 2y minus 3 equal to 0 and x plus y plus 5 equal to 0. Given the separate equations, to get the combined equation, just multiply the two. X into x, x square, x into y, x into 5, minus 2y into x, minus 2y into y, minus 2y into 5, minus 3 into x, minus 3 into y, minus 3 into 5 equals to 0. Combining the like terms, x square, xy minus 2yx, minus 2y square, 5x minus 3x, minus 10y minus 3y, finally minus 15 equal to 0. So the required answer is x square minus xy minus 2y square plus 2x minus 13y minus 15 equal to 0. Given the separate equations, to get the combined equation, just multiply the two and simplify the answer. Question number 2. Show that 4x square plus 4xy plus y square minus 6x minus 3y minus 4 equal to 0 represents a pair of parallel straight lines. Given the combined equation of pair of parallel straight lines, let us compare ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, the general second degree equation. As I compare a equals 4, 2h equals 4, so h is equal to 4 by 2, that is 2. B equals, no number tells me 1. 2g equals minus 6, g equals minus 6 by 2, that is minus 3. 2f equals minus 3 or f is equal to minus 3 by 2. C equals minus 4. As I compare the given equation with the general second degree equation, we have identified A, B, C, H, G, F. The lines will be parallel if they satisfy the condition h square equals AB. So as I apply, h square is 2 the whole square, that is 4. AB 4 into 1, that is 4. They are equal. H square equal to AB tells us the given pair of lines represent parallel straight lines. Question number 3. Show that 2x square plus 3xy minus 2y square plus 3x plus y plus 1 equal to 0 represents a pair of perpendicular lines. Let us compare the given equation with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. A equals 2, 2h equals 3, so h is 3 by 2. 2g equals 3, so g is 3 by 2. 2f equals, no number tells us 1, so f is 1 by 2. C equals 1. B equals minus 2. As we have compared and identified A, B, C, H, G, F, condition for perpendicular lines is A plus B equal to 0. So perpendicular lines, the condition is A plus B equal to 0. What is A? 2, B minus 2, A plus B is 0. If A plus B is 0, we can declare the given equation represents a pair of perpendicular straight lines. Question number 4. Show that 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equal to 0 represents a pair of intersecting lines. Show that the angle between them is tan inverse 5. As we write the given equation, let us compare with the general second degree equation. Identify A 2, 2h is minus 1, h is minus 1 by 2, B minus 3, 2g is minus 6, g is minus 3, 2f is 19, f is 19 by 2, and c is minus 20. Remember the condition. For intersecting lines, it is ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. As we substitute the values from the given equation, take LCM and simplify, we arrive at 361 minus 361 by 2, that is 0. So, we have shown the given result to be 0. Hence, it represents a pair of intersecting lines. Angle between the two lines is theta equals tan inverse 2 root of h square minus ab by a plus b. As we substitute for h, minus half, a, 2 and b minus 3. 2 into h square is 1 by 4, ab is 2 into minus 3, 6, because minus into minus is plus. 2 minus 3 is minus 1. Taking LCM, 24 plus 1 by 4. 25 by 4 is 5 by 2. Cancelling 2 and 2, we arrive at tan inverse 5. Since modulus is coming, ignore the negative symbol. So what is my answer? Theta equals tan inverse 5 is proved. Question number 6. Find the equation of pair of straight lines through 1, 3 and perpendicular to 2x minus 3y plus 1 equal to 0 and 5x plus y minus 3 equal to 0. Given 2x minus 3y plus 1 equal to 0, the perpendicular line will be interchange x and y coefficients, change the symbol. So it is 3x plus 2y plus k equal to 0. It is passing through 1, 3. That tells me this must satisfy the equation. 3 into 1 plus 2 into 3 plus k equals 0. 3 plus 6 plus k 0 or k equals 3 plus 6 9 goes to the right as minus 9. So what is the perpendicular equation? 3x plus 2y minus 9 equal to 0. The same pattern. The next line is 5x plus y minus 3 equal to 0. Perpendicular line will be interchanging the coefficients. No number tells me 1. 1 into x, 5 into y. Change the symbol. Also the constant. Already we used k. So let me put k1 equals to 0. This is passing through 1, 3. Substituting 1 minus 5 into 3 plus k1 0. 1 minus 15 plus k1 0 or k1 equals 14. So the equation will be x minus 5y plus 14 equal to 0. The separate equations are 3x plus 2y minus 9 equal to 0 and x minus 5y plus 14 equal to 0. To get the combined equation, let us multiply 3x plus 2y minus 9 into x minus 5y plus 14 equal to 0. As I multiply 3x into x, 3x into 5y, 3x into 14, 2y into x, 2y into minus 5y, 2y into 14, minus 9 into x, minus 9 into minus 5y, minus 9 into 14 equals to 0. Let us simplify and arrive at the answer. 3x square minus 13xy minus 10y square plus 33x plus 73y minus 126 equal to 0 is the equation of pair of straight lines with a given condition. Question number 7. Find the separate equations. 3x square plus 2xy minus y square equal to 0. As I read the equation, it's a combined equation. I need to factorize. 3 into minus 1, I get minus 3. And I want 2. So what are the two numbers? 3 and 1. We get plus 2 here. So it is plus 3 minus 1. Let me write it here. How should I write it? 3x square plus 3xy minus 1xy minus y square equal to 0. This middle 2xy we have split as 3xy minus 1xy. Let me combine these two and these two. Which is common? 3x. If I take it out, x plus y. In these two, minus is common, also y. If I take it out, it is x plus y, that is 0. Taking x plus y common again, it is 3x minus y, 0. So writing the separate equations, I get x plus y 0 or 3x minus y equal to 0. Take and write the answer. The separate equations are x plus y equal to 0 and 3x minus y equals to 0. Question number 7. Find the separate equations. 6 into x minus 1 the whole square plus 5 into x minus 1 into y minus 2 minus 4 into y minus 2 the whole square equal to 0. Let us expand and simplify. As we expand x minus 1 the whole square, multiply the two factors and y minus 2 the whole square. Let us multiply 6 into, here 5 into, here 4 into. Combining the like terms, we get 6x square plus 5xy minus 4y square minus 12x minus 10x minus 22x minus 5y plus 16y is 11y. 6 plus 10, 16 minus 16 cancels. So this is the combined equation. To get the separate equations, consider the x square, xy and y square term. 6x square plus 5xy minus 4y square. Like the previous problem, let us factorize this. 6 into minus 4 and I need 5. What are the two numbers? 8 3s are. Because I have plus here plus and here minus. Substituting it here, 6x square plus 8xy minus 3xy minus 4y square. Combining the first two and the last two. Here 2x is common. Having taken 2x, it is 3x plus 4y. From these two, minus y is common. I get 3x plus 4y. So we arrive at 3x plus 4y into 2x minus y. Once I know the two factors, in the previous problem we had only the three terms. So we just put them equal to 0. But now we have some extra terms. So we need to introduce some constants here. So I am introducing with the first bracket say L, with a second bracket say M. So what would be the two equations? 3x plus 4y plus L into 2x minus y plus M equal to 0. This let us mark number 2. The obtained combined equation let us call number 1. Compare 1 and 2 because both represent pair of straight lines only. Compare for what? Coefficient of x and coefficient of y. As I compare, what are the two equations we get? When I compare x, x from the first bracket, constant from the second, constant from the first and x from the second. So what is my equation? 3 into m plus 2 into L. The coefficient of x in first equation is minus 22. In the same way, let me compare y coefficient. How to get y? Y from first bracket, constant from second bracket, 4 into m. Then constant from first bracket, y from second bracket, L into minus 1 is minus L equals to. Y coefficient here is 11. Now let us try to solve the two equations. Mark this as number 3 and this as number 4. Let me multiply fourth equation by 2. I get 8m minus 2l equals 22. And third equation, let us write as it is. 3m plus 2l equals to minus 22. Adding, I cancel these two. 11m is 0 implies m equals 0. Once I get m value, put it back in 3 or 4. Let me substitute in third equation. 3 into 0 plus 2 into L equals minus 22, or L equals minus 22 by 2, that is minus 11. As I know what is L and M, put them back in second equation. So what is second equation? 3x plus 4y plus L, that is minus 11, into 2x minus y plus 0 equal to 0. So we will write the separate equations. How to write the separate equations? Each bracket let us put 0. 3x plus 4y minus 11, 0. 2x minus y equal to 0. The question is to find the separate equations, and we have arrived it. The given equation we have simplified to arrive at a pair of straight lines in the general second degree equation. Consider x square, xy, y square terms alone. Factorize, get the two factors. Now, to compare x and y coefficient, let us introduce two constants. Say L in the first factor and m in the second factor. As I multiply the two factors, call it as 2. The original combined equation let us call as 1. We compare 1 and 2 for coefficient of x and y. As I compare, I solve them. I get what is L and M. Put them back in second equation, from which we write the separate equations. Try the third subdivision yourself and verify your answer. 2x square minus xy minus 3y square minus 6x plus 19y minus 20 equal to 0. Consider the first three terms. Say x square, xy and y square. 2 into minus 3 minus 6. As we factorize, we get 2x into x plus y minus 3y into x plus y, or x plus y into 2x minus 3y. Introduce L in the first factor and m in the second factor, and as I multiply, I mark it as number 2. This is combined equation. This is also combined equation. As we compare 1 and 2 for coefficient of x and y, how to get coefficient of x? X from the first bracket, constant from the second. Constant from the first, x from the second. So x into m, L into 2x. I need only the coefficient. So x into m, write only m. L into 2x, write only 2l. Here the coefficient of x is minus 6. For coefficient of y, y into m, write m. L into minus 3, minus 3l. The coefficient of y is 19. As we solve the two equations, we get L as minus 5 and m as 4. Putting them back in the second equation, we get the combined equation, from which I write the separate equations by putting first factor 0 and second factor 0. Try to do it yourself and verify your answer.